In this example, we're looking to solve for x in this rational equation. So whenever we're looking at a rational equation, there's a lot that's going on like right away. And the first thing you want to look at is just understand the domain restrictions, meaning which value will zero out our denominators. And since we have variables in the denominator, that's definitely something that we want to look at immediately. So we have x minus 3, x plus 5, and then we have this x squared plus 2x minus 15. So we have some factoring that we need to do. So let's take care of that first, and then we'll return back to the domain. But if we didn't have to like factor anything, we can just identify the domain from that point. But we do have to factor, so let's go ahead and just knock that out first. So 7 over x minus 3 minus 5 over x plus 5 equals negative 10 over, and then factoring. So we are factoring a trinomial here. So I'm going to do this over here. So factoring x squared plus 2x minus 15 in this form of a trinomial with that a value being 1. So the a value being this is our a, b, c, so ax squared plus bx minus plus or minus c. So since our a value is 1, all we have to do is look for two numbers that multiply to negative 15 and then add up to positive 2. So two numbers that multiply to negative 15 could be 5 and 3, or negative 5, positive 3, negative 3, positive 5. We just have to play around with the signs a little bit. So since we want to multiply to a negative adding up to a positive, we're going to have our bigger number be the negative, or I'm sorry, the bigger number be the positive. 5 times a negative 3 is negative 15. 5 plus a negative 3 is a positive 2. So those are going to be my factors. So x plus 5 times x minus 3. Wouldn't be terrible to look at the other denominators and see if you can get lucky and maybe those are the factors. And sometimes that works out, sometimes it doesn't. But it never hurts to just like peek at those and just see like, all right, well that was a positive 5, so let me try 5 and 3 and see if it works out. So now that we have that, we have to establish which x values the answers cannot be. So we're going to take our denominator, so x minus 3 equal to 0, x plus 5 equal to 0, and I don't need to do this because they're the same, x plus 5, x plus 5, x minus 3, x minus 3. So this is going to be x equal to 3, so x cannot be 3. And this is going to be x equal to negative 5, so x cannot be 3. And x cannot be negative 5. So just something to keep in mind when we get down to our solution. So our next step is actually starting the process of solving this now. In order to solve this, what we want to do is we want to identify a least common denominator. So least common denominator. So x minus 3 is going to be a part of that conversation. So we have x minus 3. X plus 5 is going to be a part of that conversation also. Then over here I have x plus 5, x minus 3. So those are the same as our other two denominators. They're just multiplied together. So that's great. That's going to be completely fine. And we can just multiply now by our least common denominator. So I'm going to multiply both sides by the least common denominator. So this is going to be x minus 3 times x plus 5 times all of this. And then here, x minus 3 times x plus 5 times all of this here. Well, just one term here. But here is really the key. When you multiply this out, you really want to be careful here. You want to do x minus 3 times x plus 5 times this. X minus 3 times x plus 5 times this. You want to make sure you're multiplying it to both. Common mistake is you'll multiply the x minus 3, x plus 5 times this first term. You'll notice the x minus 3's cancel, and then you forget about that x minus 3 times here. But that doesn't happen. You got to make sure you're multiplying this whole statement by this times this. Everything gets multiplied. So we're going to do this carefully. So I'm going to have 7 times x minus 3 times x plus 5 over x minus 3 minus, and this is going to be 5 times x minus 3 times x plus 5. And once you get comfortable with this process, this is definitely not something that you need to write down every single time that you do rational equations. Like you could probably just make the cancellations more mental and then just know what you have to multiply there. Over here, I'm going to take a little bit of a shortcut. I noticed that x minus 3, x minus 3, x plus 5, x plus 5. So boom, bam, bam, boom, gone, leaving me with only a negative 10. Now on the first term, I have this x minus 3 over x minus 3, boom, x plus 5 over x plus 5, gone, leaving me with, on this side, 7 times x plus 5. Here is another big part of this problem. So the first was making sure that you don't cancel these out and then forget to distribute. The second big mistake is right here. See how this was minus 5 times all of this? So when you write this down, you have to do negative 5 times the x minus 3 equal to negative 10. Meaning, this has to be negative 5 times x, negative 5 times negative 3. It's another huge part where you can make a mistake here is forgetting about that negative, and that has to be multiplied into there. So then we're going to also distribute the 7, so 7x plus 35. Negative 5 times x is negative 5x. Negative 5 times negative 3 is a positive 15, equal to negative 10. Moving right along, the whole goal with multiplying by the LCD is to wipe out the denominators, leaving us with this nice manageable equation that we could solve. So then we're going to solve this. 7x minus 5x, 2x, 35 plus 15 is 50, equal to negative 10. I'm going to go over here. So solving this, I'm going to subtract 50 from both sides. That's going to give me 2x equals negative 10 minus 50 is negative 60. Divide by 2, x equals negative 30. Before you circle this or box it up and move on, you want to double check that we are not breaking any sort of rules that we've established. We established that x cannot equal 3, x cannot equal negative 5, x equals negative 30. That's good to go. Cool. I am done. So 2 key steps right here, and right here. If you're going to make a mistake, it's probably going to come somewhere in there. And this problem isn't the cleanest or simplest. Like this factoring could even be a little messy at times. But if you catch yourself here and catch yourself there, then I think you should be okay in the long run.